All right, again, find the 4-6, day 6 notes. At the beginning of our work with logarithmic functions, we discovered that a logarithm is the inverse of an exponential function. So let's highlight that. A logarithm is the inverse of an exponential function. We were able to find the graph of the logarithm from the points of the exponential. Recall the steps of finding the equation of an inverse. We switch x and y, then solve for y. So do you notice my table talk? We need this information, so I'm going to keep at it and keep at it. So in example 1, it says find the equation of the inverse. So step 1 is you are going to switch the x and the y. So now that's going to be x equals 2 to the y power. Now here is the power and the purpose of a logarithm. My y value is in the exponent, and the only way to get it unstuck is by going from exponential to logarithmic form. So here we go. This is the log, my base is the base, so it's going to be the log with base 2 of x equals y. Now that is the inverse, okay? That is the inverse, so I'm going to put the little -1. So let's write something down here. Big idea. When you want to find the inverse, switch x and y, solve for new y. If y is in the exponent, you rewrite in log form. So as you do homework tonight, and when we eventually get to reviewing, you want to read through these notes. So again, the big idea here when you want to find an inverse is switch x and y, solve for new y. If y is in the exponent, you rewrite it in log form. So let's look at example 2. I have y equals log with base 3 of x. So it says switch x and y. So I'm going to get x equals log with base 3 of y. So let's write ourselves a note. If y is inside a log, let me unplug just real quick here. So if y is inside a log, there we go, then you rewrite in the exponential form. So, where I have x equals log with base 3 of y, this becomes 3 to the x equals y, and I'll make it y inverse. So anytime y is stuck in an exponent, we go to logarithmic form. If y is stuck inside a logarithm, we go to exponential form. And that undoes it for you. So let's look at example 3. It says find the equation of the inverse of y equals 3 times 2 to the x power minus 1. So we're going to switch the x and the y. So you now need, we're trying to solve this for y, but you have to first get the base alone. So what do I need to do first? What would be my first step in trying to get the exponential? Yeah, Angelo? Yes, you're going to start by adding 1 to both sides. And again, I'm trying to get 2 to the y alone. Yeah, Davey? And I do not want to divide by 3 first, because if I do that, I have to divide the 1 by 3 as well. You see that? But at this point, I do want to divide by 3. So this will give me x plus 1 over 3 equals 2 to the y. Now this one's going to be super ugly. It's ugly but true. This will be the base is the base. The answer to a logarithm is the exponent. And then I'm just going to call it y inverse. So step 1 has always remained the same. When you want to find an inverse, we switch the x and the y. However, when I'm trying to solve for y and it's in an exponent, I have to get that 2 to the y alone. So I had to add the 1, then divide by 3, then I have 2 to the y alone. And what I'm doing is I'm going from exponential form to logarithmic form. So the base is the base. The answer to a logarithm is the exponent. So that just makes the x plus 1 over 3 go inside the log. All right, let's try example 4. Find the equation of the inverse of y equals 2 times log x minus 3. So step 1, switch the x and the y. Now I have to get the log y alone. That means anything after it, anything in front of it. But I have to undo order of operations. So what would I do first to try to get the log y alone? Add 3 to both sides. So I'm going to go x plus 3 equals 2 times the log of y. Then what do I do? Divide by 2. Divide by 2, and I get x plus 3 over 2 equals log y. Before I continue, I need to remind you of something we did a few days ago. When I see LOG with no base, what's the implied base? 10, okay? That's called the common log. If it helps you, let's put the little 10 in. If you don't need it and you're like, I remember it, then don't do it. You do whatever you need. So now I have my log alone, but I'm trying to get the y out. So the only way I can do that is to go from logarithmic to exponential. So my base is my base. The answer to a logarithm is the exponent. So this is super ugly. Okay, this is like super ugly, but it's true. This is the answer. So my base is my base. The answer to a logarithm is the exponent. So my exponent is x plus 3 over 2. Then the last thing I like to do is tidy that up and call it y inverse. All right, so what I'm going to do now is I want you to scroll, and I just put some practice problems. What I want you to do is I'm going to give you about 5 or 6 minutes, and I want you to do as many. I don't expect you to be able to get them all done. I went a little overkill on this. So just try as many of these as you can. Okay, I'll put the first one up just because I know that you're like, okay, am I doing this right? It looks really weird. So you're going to switch the x and the y. You do need to divide by -9 first. Then I'm ready to go. I'm ready to put this in exponential because I have the log alone. So this is going to go 5 to the x over -9 power equals y. And it's okay if you made the negative up in the top and made it 5 to the negative x over 9. That's okay. All right, I'll do the second one so some of you can check it. So I switch the x and the y, and I do have the log as alone. It has some stuff inside of it, but I don't have anything in front of it and nothing after it, okay? So I can't add 10 to both sides because that 10 is inside the logarithm. Does that make sense? That's different from like number 3. And number 3, this plus 1 is not inside. Yeah. So now, from here to here, I'm doing logarithmic to exponential. The base is the base. The answer to a logarithm is the exponent. So it's 6 to the x. It's just like how I went from here to here. So you don't just solve it from there to there. When I'm here, I cannot get that y outside of a logarithm. You cannot add 10 because it's inside a logarithm. So the only method I have mathematically is to go from logarithmic to the equivalent exponential form, and then the y is outside of the logarithm. Okay? Maybe I'll change colors so you can see what I'm doing here. So here's number 3. I switch the x and the y. Now I need to get that log with base 5 of y alone. So I subtract the 1. And then I'm going from logarithmic to exponential. So 5 to the x minus 1 equals y. And that y is the inverse. You can, because I subtracted, it's not inside. Yes, absolutely. And if it meant to be inside, then it'd be from inside. All right, I'll just keep working a couple more. Okay, here's number 4. You switch the x and the y. So I get x equals log with base 4 of 3y. Then I'm changing colors when I'm going from logarithmic to exponential. So that's 4 to the x equals 3y. Now I divide by 3, so I have 4 to the x divided by 3 is the inverse. You're trying to get y alone, so you would subtract the 5. Okay, so I'm hearing the same question over and over again. And here's kind of our big idea. Let me make sure. If I have the log base b of x, let's say equals y, the equivalent exponential form is the base is the base, the answer to the log is the exponent equals y. I'm using this. Every time I'm changing my colors, this is where I'm going from the logarithmic form to its equivalent exponential form. That's what I'm actually doing. So let me jump to number 6. I get x equals log with base 4 of 2y minus 9. I cannot do this until I get the logarithm alone. This logarithm is not alone. What do I have to do first in number 6? Add 9 to both sides. So I would get x plus 9 equals a log with base 4 of 2y. Now I'm going to change my colors. Now that's 4 to the x plus 9 power equals 2y. And I divide by 2. Now, can I take the 4 divided by 2? and say that's 2 to the x plus 9? No, because of the exponent. Exponent's order of operations, I cannot divide before the exponent. All right, just because of time, I want to jump to number 8. Okay, I want to jump to number 8. So this would give me x equals, and I'll work out 7 in a moment, but I just because of time, because I want to get to my example 5. This was just some partner practice. I switch x and y, and I'm trying to get the e to the y power alone. Okay, I switch x and y, and I'm trying to get my base to a power alone. Now, this is going to become log base e of x minus 5 equals y. I don't ever leave log base e. I know you're first learning it, so it's okay to start with it. But what is log base e? ln. So we're going to change that to ln x minus 5 equals y, and I'm going to call that y inverse. All right, real quickly, I'll work out 7 for those of you that were there. This one was tough. This is a cube root. Or to the 1/3 power. That would be okay to write it to the 1/3 power. All right, I am going to go ahead and jump to, I know we're not finishing these and you don't have to finish all these. These were just a ridiculous amount of extra practice. I'll post all of them for those of you that want to work them. Yeah. Let's look at example 5. Okay, let's look at example 5 for me. Now, if you want to solve an equation, what you want to do is you want to isolate b to the x or log x. Okay, go ahead and write this down above example 5. When you are solving equations, and notice these are exponential in the top row and logarithmic in the bottom row, you have to isolate your b to the x or log x. That's your first step. And then the second step is rewrite in either log or exponential form. So if you're in exponential, you'll write it in log form. If it's log form, you'll write it in exponential form. And this will help you to solve. So let's do a few of these. If I have 12 to the x equals 56, so I'm not doing an inverse. Let me stop here a moment. We're not doing an inverse. Do you understand that? Nowhere does it say find the inverse. This is solve for x. So my x, my 12 to the x is alone on the left side. So all I'm going to do is I'm going to rewrite this now in logarithmic form. My base is the base. The answer to a logarithm is the exponent in exponential form. So this is log base 12 of 56 equals x. Grab your calculators. I see most of you have them out, which is awesome. If you don't, grab your calculator. And the directions say round 4 decimals. So I got 1.6199. You getting that on the calculator? If you have your calculator? Okay. All right, letter B. What do I have to do first in order to get e to the x alone? Becca? Good job. You're going to add 8 to both sides, and that'll give me e to the x equals 51. Now, in order to get that exponent to come out, I go from exponential to logarithmic form. So my base is e, so this will be log base e, 51 equals x. Well, log base e is ln. On your graphing calculators, you have an ln button. So I got 3.9318 for x. All right, letter C. What do I need to do first to try to get my 16 to the x alone? I got to do a few things here. Yes, Sydney? Good. Okay, let's subtract the 3. So that'll give me 55. And then you're going to divide that by 6. Then this is log base 16. And of course, you could put a decimal there is fine. Or just wait till you're done. All right, now the next two are logarithms. So I'm trying to get my log alone. So what would I need to do to both sides of this equation to get the log alone? Subtract 1 from both sides. When it's log and there's no base indicated, what base is it? Base 10. Once you have the log alone, okay, so it's the log of some stuff. It's okay that there's an x minus 2 inside. That's the inside of the log. That's all right. Then you're going to go from logarithmic to exponential. So 10 to the second equals x minus 2. Oh, yes, thank you. Whoops. There you go. Yes, that's 10 to the negative 2, which is 0.01, and then I would add 2 to both sides. So it's 2.01. All right, let me give you a head start on letter E. Try to get the logarithm alone. Once you have the logarithm alone, then go from logarithmic form to exponential form to try to get the x out of there. And you should be getting x equals negative 18.